is it commercially viable? Well, I think that the feats of animals are incredible, right? We underappreciate what animals can do. As Jan LeCun often says, we have AI systems that can prove theorems and do all these amazing things, play Go, but where's my AI that can do what a cat can do?
Yeah.
Right.
Yeah.
Right. Even a mouse or even an insect, they have amazing capabilities. And for embedded systems, so we don't just need AIs to talk to us, right? We want robots. For a lot of robotic applications, embedded applications, we don't need language. That's not the fundamental problem. A lot of intelligence is pre-linguistic. So I think that the study and emulation of animal brains is in some sense better to do than, I mean, why would we compete head to head with language models right now?
Yeah.
Right. We should be working on the stuff that language models can't do. And animal brains are perfectly a great example of that.
Cannot tell if this is a stupid question, but yeah, I mean, couldn't you make like the most, if you got the mechanics of this fly down, I mean, the most amazing drone you could imaginable?
Sure, if you can try to attack a drone, a fly with a fly swatter, and see it's got a pretty sophisticated
Yeah.
escape capability, right? So, and if you think about insects generally, right? There's a million species of insects. Think about all the nature shows showing you what these insects can do. They have incredible capabilities, and tiny brains,
Right. So,
tiny
because
brains, right?
so there would be part of this where if we reverse engineer these mechanics and then you can somehow like infuse it into a robotic system, I mean, you could get these.
Yeah, I think we can make lightweight neural nets that can run with low power in minimalist hardware, and that's going to be useful for these embedded systems, right? And ultimately, also, people have been talking about AI chips that are really based on brain structure, right?
Yeah.
Neuromorphic systems. And one of the problems with the whole neuromorphic field has been that we didn't really know what neuromorphic was. We didn't have the structure of the brain, but now we do, right? And so this is going to suggest new ways to think about how to build these incredibly efficient AI chips that are efficient using some of the brain's tricks.
Yeah. Yeah. No, that is what I was, I mean, because I hear all the time of human brains are so efficient. We're gonna mimic this. It feels like we have so far to go. When I see I go out to Stargate and see the size of this data center, it's like, okay, and it's the same thing you were talking about with Jan LeCun. I mean, there's this part where the AI system already can do things I can't. Can read every physics paper on that's ever been written. It has, and I'm never ever going to do that. But then I can do all this other stuff so much more efficiently on my piece of toast in the morning than this thing huffing natural gas can out in Texas. But yeah, it's hard for me to imagine actually bridging that gap in some reasonable time frame. But
Another thing that's happened is that chip making technology has become 3D. So a big difference between integrated circuits and the brain was that integrated circuits were fundamentally 2D, very planar. Everything's laid out on the surface of silicon, right? Whereas the amazing thing about the brain is this 3D, your head is jam-packed with wires and you have this 3D interconnect. But if you look at chip making technology now, it's becoming more and more 3D, especially memory technology. I think NAND flash, they can have 1,000 layers of memory cells now. So it's really becoming 3D. And so that means there's a potential for making chips that are much more like the structure of the brain with this biological interconnect.
Yeah. All right.